friends. Hello. Today we'll discuss about normalization, its need, normal forms up to the third normal form and functional dependencies. So let's start with the definition of normalization. What is normalization? Normalization is the process of organizing the attributes and relations of a relational database to minimize redundancy and dependency. Here, minimizing the redundancy means minimizing the duplication of data in various relations. For example, the customer personal details be kept in one relation, and for making relationships between two relations, say customer and order, only the customer ID to be copied in another relation order. Thus, duplication is minimized to customer identification only, which is impossible to avoid. Thus, we have minimized the redundancy, but it cannot be removed. Normalization usually involves dividing large relations into smaller relations and defining relationships between them. It is a step-by-step process of replacing a given relation with a collection of successive relations to achieve simpler and better data representation. There are mainly three normal forms, namely first normal form denoted by 1NF, second normal form denoted by 2NF and third normal form denoted by 3NF. All these normal forms are based on functional dependencies among the attributes in a relation. In the process of normalization, single relation is decomposed into a number of relations based on the primary key or candidate key and the functional dependencies among the attributes. In normalization process, two criteria are to be satisfied during decomposition. First criteria is lossless decomposition. It ensures no loss of information during decomposition. If it is possible to reconstruct the original relation by joining the decomposed relations, then it is called lossless decomposition. Second is dependency preserving decomposition. Decomposition is said to be dependency preserving if the union of the functional dependencies in decomposed relation is equivalent to the closure of the functional dependencies of the original relation. Now, when we are cleared with what is normalization, the question arises, why do we need normalization, or what are the problems that may occur without normalization? So, without normalization, it becomes difficult to handle and update databases without facing any loss. This is due to different anomalies that occur during so, that is update anomalies, insert anomalies and delete anomalies. Anomalies are inconvenient or error prone situation arising when we process the relations. So, the main objective of normalization is to eliminate different anomalies. To discuss anomalies, look at this table please. Let us consider a relation student with attributes stu underscore id, stu underscore name, address and course as shown. So, first anomaly is update anomaly. An update anomaly exists when we need to update one or more instance of the duplicated data. Then there may arise a case when all the data instances will not be updated. This will left the relation in an inconsistent state. This phenomenon is called update anomaly. For example, consider Mnohar's address. We need to update all the instances of Mnohar's address to eliminate update anomaly. If it is updated in one tuple and we forget to update in another, it may lead to inconsistent data in the relation. So, next anomaly is insertion anomaly. During insertion of new data in the relation, there may arise cases where certain facts cannot be recorded at all. For example, suppose in our relation student, for a new admission we have students all the details like stu ID, stu name and address, but if student has not opted any of the courses yet, then either we have to insert null for the course attribute, or it might happen that such system does not allow to enter the details of a student who have not opted any course. So, this phenomena is known as insertion anomaly, which hinders the insertion of new data into the relation. So, our last anomaly is deletion anomaly. During the deletion of some particular field of record, it becomes necessary to delete other details also, whether they represent total different meaning. For example, a relation student suffers from this type of anomaly. For example, if a student, say student ID 24 is temporarily seized from some course, we must delete the last course that student took on which the record of that student is also deleted. In this way, the information regarding the student is also permanently deleted, and in future if we want to find the details of the student for any purpose, we will not be able to find as it has been deleted, and this phenomena is known as deletion anomaly. Thus, it is concluded that a relation is said to be in normalized form if it is free from all these three anomalies. So, before starting our discussion on normal forms, we need to learn about functional dependencies. So, what is functional dependency? Formally, a functional dependency can be defined as, in relation R, an attribute or set of attributes y is said to be functionally dependent on another attribute or a set of attributes x, denoted by x arrow y, which is interpreted as x determines y or y is functionally dependent upon x. If each value of x is associated with exactly one value of y, thus y is functionally dependent upon x, or we can say that x functionally determines y. For example, look at this relation. In the given relation, the attribute d name is functionally dependent upon attribute department. This means that corresponding to the value 20 for the attribute department, always there is mapping to the value accounts in the d name department. In other words, corresponding to each value of the attribute x, there must be only one value mapping in the attribute y. Then we say that x is functionally determining y, or y is functionally dependent upon x. So, in relational data model, various type of functional dependencies may exist, which are fully functional dependency, partial functional dependency and transitive functional dependency. So, first is fully functional dependency. An attribute or a set of attributes y is said to be fully functionally dependent on another attribute or a set of attributes x if it is functionally dependent on x, it is not functionally dependent on any proper subset of x. For example, consider an relation employee with attributes id, name, address and department. Now, address has a functional dependency on the set of attributes ID and department in collection. We can say the set ID department functionally determines address, or address is functionally dependent upon ID department set. So, but this address attribute is functionally dependent, but not fully functionally dependent on this set, because address attribute is also functionally dependent on ID. That is, ID functionally determines address. Thus, it is also dependent on the subset of ID department set, which is not allowed in fully functional dependency. So, next type of functional dependency is partial functional dependency. In a relation R, a functional dependency of the form x arrow y is said to be partial if the dependency persists even when any attribute is removed from x, that is, the subset of attribute x is good enough to maintain functional dependency among x and y. For example, reconsidering our previous relation employee, there was functional dependency. ID department set is functionally determining address, and address was also functionally dependent on ID alone even after the removal of the attribute department. So, this type of dependency is known as partial functional dependency. So, address is partially dependent on the set ID department. So, next type of functional dependency is transitive functional dependency. Transitive functional dependency is an indirect functional dependency. Consider a relation R in which y is functionally dependent on x and z is functionally dependent on y, that is, x determining y and y determining z. Then z is functionally dependent on x via the rules of transitivity. In this case, the functional dependency x arrow z is called transitive functional dependency. For example, consider the given relation. Here, department is functionally dependent on staff number and D name is functionally dependent on department, that is, staff number determines department and department determines D name. Then by rule of transitivity, D name is functionally dependent on staff number. So, staff number functionally determines D name. So, after learning about the concept of functional dependency, we are ready for the normal forms. So, starting with the definition of normal form. What is a normal form? A database is said to be in normal form if it has a defined standard structure and it satisfies the rules required by that relation. It also will not suffer from any of the anomalies addressed by the relation. Thus, in each normal form, there are some known requirements and a hierarchical relationship exists among the normal forms. Therefore, if a relation satisfies the requirements of second normal form, then it automatically satisfies the requirement of first normal form. So, we will be covering only first, second and third normal form only. Let us start with the first normal form, and in short we say 1NF. A relation is said to be in 1NF if and only if all of the underlying attributes of the relation are atomic. In other words, a relation that is in first normal form should be flat with no repeating groups. a relation in one NF must not contain any composite attribute or multi-valued attribute. Look at the table. So, consider a relation student with attributes SID, name, address, CID, CNAME as shown. In this relation, SID is the primary key attribute and address is a composite attribute that consists of the simple attributes street, city and state. Also, each course has a unique course ID and any student can enroll for each of any course. The set of functional dependencies that exists among the attributes of the student relation are as the above relation does not satisfy the requirements of one NF because it contains a composite attribute address. Now, to transform this relation into one NF, the composite attribute address is to be represented by its components street and city. To convert a relation to one NF, composite attributes are to be represented by their component attributes and the multi-valued attributes are to be represented by using separate tables. So, after applying one NF, the resulting relation will consist of attributes SID, name, street, city, CID and CNAME. So, consider another example also in which we will eliminate repeating groups. Consider the table shown in which we have an unorganized relation course with attributes course and content as follows. So, after applying one NF, we will get relation as shown. So, in which repeating groups have been eliminated. So, next normal form is second normal form. A relation is said to be in 2 NF if it is in 1 NF and there must not be any partial dependency of any attribute on primary key. All non-prime attributes of the relation must fully functionally dependent on the primary key attribute. To convert a relation from 1 NF to 2 NF, all partial functional dependencies are to be removed. So, non-prime attributes are those attributes of the relation that are not the part of the primary key. For example, consider a relation order with attributes order number, product description, unit price, order quantity and total as shown. So, here attributes product underscore description and unit underscore price are partially dependent on product underscore number. So, we remove them from the relation order and place them in a new relation named product with product number as primary key, as these attributes are dependent on the product number, and rename the relation order to order 2 with attributes order number, product number, order quantity and total. Now, our two relations product and order 2 are in 2 NF. Consider another example with the relation customer as, here combination of customer ID and order ID is the primary key and customer name, order name and sale detail are the non-prime attributes. This table is in first normal form, but not in second normal form because there exists partial dependency. Customer name is only dependent on customer ID. So, this is partial dependency over here. Order name is dependent on order ID, again it is a partial dependency over here, and moreover there is no link between sale detail and customer name. To reduce customer relation to second normal form, we break the relation into following three different relations, keeping their names as customer underscore details consisting only customer ID and customer name relation, order underscore detail relation consisting of order ID and order name attributes, sales underscore details with the attributes order underscore ID, cust underscore ID and sale underscore detail. So, these are the relations. Now, all these three relations are in 2NF, that is the second normal form. Now, our last normal form is third normal form. A relation is said to be in third normal form or 3NF if it is in 2NF and no known prime attributes in the relation must be transitive dependent on the primary key attribute. To convert a relation from 2NF to 3NF, all transitive dependencies are to be removed. Let us look at an example by reconsidering the relation student we considered in example of first normal form. The relation student was in 1NF which has been converted into 2NF. Thus, the shown relations are in 2NF, but it does not satisfy the condition to be in third normal form as it contains transitive dependencies. In this relation, attribute CNAME is functionally dependent on CID and CID is further functionally dependent on SID. So, to convert the relation student in 3NF, it is decomposed into two new relations, student 1 and student 2 as shown. So, relation student 1 has attributes SID, name, street, city and CID, and relation student 2 has the attributes CID, CNAME. So, here attribute CID of relation student 2 is the foreign key of the relation student 1. So, now both the relations are in the third normal form. Let us look at one more example to understand the concept in a better manner. Consider a relation student underscore details with attributes ID, name, date of birth, street, city, state and zip. In this relation, ID is primary key, but street, city and state depends upon zip, that is zip functionally determining this set of attributes, whereas zip depends on ID. This dependency is transitive dependency. Hence, to apply 3NF, we need to move the attributes street, city and state to new relation with zip as primary key. So, our resulting new relations will be relation student underscore detail with attributes ID, name, date of birth, zip, and the relation address with attributes zip, city, street, state. So, here attribute zip of relation address is the foreign key of the relation student underscore details. Both the relations are in third normal form now. With this, we come to an end of today's lecture. Today, we have discussed about normalization, its need, functional dependency and normal forms up to the third normal form. In the next lecture, we will learn about ER to relational mapping. Thank you.